All right. So, can you hear me okay and see the board okay, Dave? Or there's a there's a bit of glare in the middle. Yeah. And let me know if it gets any better. Oops. What happened? Yeah. Can you hear me okay now, Dave? Dave, you're on mute. Can you hear me and see the board okay? I'm sorry? No, I'm not able to hear you, sir. Can you hear me and see me okay?
Yes.
Okay. Okay, wonderful. So, what are we starting with today? Are we starting with anything new or we will stay with the old story? Any guess? Okay. So, we'll continue the same stuff. We talked about permutation, we talked about combination, and now we have to combine both the concepts to see how that helps us in solving probability problems. Okay? So this is one of the complicated as well as interesting unit. That's the reason why it's taking a little longer, and that should be okay, unless you guys feel otherwise. Yeah. Okay. So, what is the basic difference between permutation and combination as per your understanding so far? What is the basic difference between permutation and combination?
Permutation order matters, combination order doesn't matter.
Okay, very simple and point blank. Permutation order matters, combination order doesn't matter. Yeah, that is the first thing. Now, and again, it comes down to you have certain options. From that, if you are picking some, if you are talking about which one comes first, which one comes second, then we are talking about permutation. If we are talking about certain things being picked up from a list of items, and then the order doesn't matter, that is combination. Yeah. Now, I'm not going to teach you guys anything new or new topic. What we'll do is we'll straight away jump into some problems and then we'll try wrapping our head around that. Yeah? Bear with me. Okay. Now let's pick up one problem and then we will try relating that with what we know. Now let's look at this problem. It says, so pay attention to what I'm saying right now, and I'll read this question a couple of times for you guys. To win a particular lottery game, a player chooses 4 numbers from 1 to 60. To win a particular lottery game, a player chooses 4 numbers from 1 to 60. Each number can only be chosen once. That means once you pick it up, you cannot put it back. If all the 4 numbers match the 4 winning numbers, if all the 4 numbers match the 4 winning numbers, regardless of order, the player wins. What is the probability that the winning number is 3, 15, 46 and 49? Quite loaded question. And that is where our silver bullet will help. So let's read it one more time. And Dave, you can hear me okay, right? I'm reading the question one more time. To win a particular lottery game, a player chooses 4 numbers from 1 to 60. So you have numbers from 1 to 60. Player chooses 4 numbers. each number can be chosen once. So you cannot repeat. Meaning once you pick up a number, you cannot put it back in the basket or in the bin. If the four numbers match the four winning numbers, regardless of order. So let's say 7, 8, 9, 12. These are four winning numbers. Regardless of the order. If you are getting 8, 12, 9 and 7, or you are getting 7, 8, 9, 12, doesn't matter. The order doesn't matter. These four numbers have to be picked up for the player to win. What is the probability that the winning numbers are 3, 15, 46 and 49? So, you guys heard this question so many times. Now, we have come to a point where I have almost memorized this question. Right? So, it says, in a lottery game, you have numbers from 1 to 60 that you can pick up.
Yeah.
Once you pick up a number, you cannot put it back. And what it says is, and for anyone to win the lottery, the four numbers have to be picked up, and order doesn't matter. So if you are given a target of four numbers to be picked up, regardless of which one is getting picked first, which one is getting picked second, so on and so forth, as long as you have four numbers that is matching, you are winning the lottery. Now it says, what is the probability that the numbers picked up are 3, 15, 46 and 49? Okay. What is the probability of this number getting picked up? Now let's go back to the basic concept of lottery, right? Everybody here. Forget about the calculator. See, again, trust me, you guys are much more smart to solve problems. Right now we are focusing on how do we organize our thoughts. Okay? So the question says the four numbers you have to pick up to win a lottery, and the organizer of the lottery will choose the numbers, right? I mean, depending on how they pick up four numbers or whatever. So in a lottery thing, okay? Let's say I buy a lottery ticket, David bought the ticket, Sai bought the ticket, Dave bought the ticket, Arush also bought the ticket, and all the kids who were supposed to be in the class, they also bought the tickets. Let's say out of 20 people buying the ticket, then only one person will probably win. Okay? Who makes money in casino? Only the owner of the casino, okay? Not people like you and me. And that's why those casinos are still there. So the deal is like this. Let's say, I'm just making it up. If 100 people are buying tickets, every ticket is worth $10. The person who's organizing the lottery event gets $1,000. What he will do? He'll say, okay, my first prize is 100, second prize is 50, and third, and these two prizes, okay? Out of the 100 people who have bought the ticket, he will only give 100 to one person and 50 to another person. Remaining $850 goes in the pocket of the person who organized the event, or the lottery guy. So eventually, every time he or she does an event, people like you and me get fooled by the idea that, okay, I'm putting 10 and I'm getting 100. And I will always assume that, oh, I'm the luckiest person on the earth. I'll put 10, I'll get 100. Eventually, everybody, all the 100 think the same way and buy the ticket. But this guy only makes the money. So, same thing works in lottery also. So here, I mean, if you look at this situation, out of the 100 people bought the ticket, only 2 people are winning. 2 out of 100. This is the probability we are talking about. Only 2%. So every lottery, every gamble, every such event is organized keeping the probability in mind. Okay? Everybody goes to Las Vegas, Choctaw, wherever you have casinos, hoping that, okay, if I win $1 million deal, I'm done for this life. I'll buy 2 houses, settle down without working. But that is not the case. For any one person to win $1 million, probably 5 million people would have put $2 each. Okay? So let's not go into that business aspect of it. What I'm trying to say is, every lottery, every gambling event is based on a probability. Okay? It looks at, okay, 200 people paying money, only one person gets it. The probability of winning is 0.5%. And remaining 99.5% profit goes into the pocket of the person who organized it. So here in this scenario, now we are coming back to this question where we have 60 numbers from 1 to 60 to be picked up from, and any combination of 4 numbers will win if those numbers are formed. Let's say if I'm juggling those numbers and I'm picking one by one and you guys are checking your numbers. Okay, so the 4 numbers that I picked up from the bin, if that matches with any of you, ends up winning. Now in this question it says you have to pick 4 numbers, okay? And we have to find out what is the probability of that winning number is this many. I talked a lot of things. Now we are trying to put a structure to our thought process. What is that we are trying to find here? We are trying to find out how many combination of 4 numbers we can get out of 60. We have total 60 numbers. How many ways we can pick 4 numbers? And the order doesn't matter. So we are talking about a combination scenario. Yeah? Now if you guys have to tell me out of the 160 numbers from 1 to 60, how many different unique combinations of 4 numbers we can find out. Do you guys remember how to do it? Let's do a quick recollection. Dave, do you remember by any chance? Okay, let me kind of help you guys recall it. So if I have 60 things to pick from, like we have 60 numbers to pick from, I have to pick 4 numbers. So I'm talking about a scenario when order matters. We are not really worried about the order right now. What we are saying is, I want to find out how many collections of 4 numbers I can find from 60. Regardless of which one comes first, which one comes second, etc. So we are talking about a combination scenario here. And that is, in case of permutation, it is factorial n by factorial n minus r. This is n, this is r. Here we are talking about 60 factorial divided by 60 minus 4 factorial. This is permutation scenario. When we talk about combination scenario, this one we have derived that okay, whatever comes for permutation divided by number of ways they are organized among themselves. So whatever comes for this one divided by factorial 4 factorial. Yep. So am I making it complicated, guys, so far? No. So let's do a quick recollection first. So we are talking about in this problem says how many ways you can find out 4 numbers out of 60 numbers that we have. Okay? Without worrying about the order. So essentially the question itself has given a very straightforward clue that without worrying about the order. So we are talking about combination scenarios. So how many ways we can pick 4 numbers from a group of 60 numbers? This one. So that gives us 60 factorial divided by 60 minus 4, that is 56 factorial and 4 factorial. So this becomes 60 by 56 will become 57, 58, 59 and 60, and divided by 4 factorial is 4 into 3 into 2 into 1. So 4 into 3 into 2, 4 3 is 12, 24. So this 12 gives me 5 and this gives me 29. And you can multiply and find whatever it is. So this is only telling me how many total combination of 4 numbers I can find out. What is the probability here? How many unique combination of 4 numbers we can find from 60 numbers? That's what we have derived using the combination formula. Now what is the probability?
Probability is the chance of
Yeah. So, how many events we are talking about? This is the number of events.
Yeah.
And what is that one unique event we are talking about? This. So, by definition, probability says probability of that event happening is only one. Only one.
Yeah.
By total number of events, which is this thing. So, which is 57 into 29 into 59. Yeah. Dave, question to you. Did I make sense or I was talking nonsense?
It makes sense for the most part.
Okay. So let me do a recap. Okay. What was the question? Question was saying that you have a lottery event where you have to pick numbers from 1 to 60 and you have to pick a combination of 4 numbers. So basically you have to pick 4 numbers regardless of the order. As long as somebody gets those 4 numbers without worrying about the order, that is the person, that is the lucky person who wins the lottery. So here in this situation, we are saying, okay, fine. It says that the order doesn't matter. So it's a combination scenario. Meaning, if you find out what is the total number of unique ways I can form a combination of 4 numbers from this many numbers. Yeah. What are the unique number of ways I can find 4 numbers from this many? 60 combination 4 or 60 compute 4 or whatever you call it, or 60 collect 4. Okay, collect 4 from 60, whichever way you want to remember this. And from that we found that this 60 combination 4 gave me this answer. This is the total number of events. So when we talk about probability of any event, that says likelihood of the event that we are talking about versus the total number of events. That gives you the probability. Right? Like if you are tossing a coin head or tail, you have 2 options total, head or tail. And what is the probability of getting a head? Head is 1 out of the 2, so 1 by 2. Likewise here, the total number of events is this much. And what is the probability of getting one unique combination 3, 15, 46, 49, that lucky millionaire for the day, is only 1. It's only one unique combination. There is no second combination you can form out of these 4 numbers, as long as you are not worried about the order. Yeah? Is it making sense now a little bit more than before? Dave?
Yes, sir. Thank you.
Okay. Sahib, with me? Okay. So now, here, the main thing is, whenever you have a problem, okay, a probability problem to deal with, there are 3 things that we need to be aware of. What is permutation? As soon as we talk about permutation, we know how to calculate. Meaning when the order matters, this is my formula. Certain events out of this many. Certain options out of this many. When we talk about combination, we are talking about unique groups that we are creating out of that many options, without worrying about the sequence among them. And third thing is probability. If I am talking about probability of an event, that is calculated by occurrence of that particular event that has been talked about versus the total number of events. That is probability. That is what we are going to put across to solve all the probability related problems based on whatever we have covered so far. So let's look at next problem, and I would not want to waste my and your energy to solve it. I would rather want to deliberate to look at how is our brain processing those problems. Okay? How do we interpret the problem, and then how do we approach this? So I am reading the next question, okay? And trust me, not every question is going to be the same. We have to just think through it in a little bit detail. Dave, are you ready for the next question? Okay. A club of 9 people wants to choose a board of 3 officers. A club of 9 people wants to choose a board of 3 officers. President, vice president and secretary. Assuming the officers are chosen at random, what is the probability that the officers are Marsha for president, Sabita for vice president and Robert for secretary? One last time I'll read it so that I memorize the question itself. A club of 9 people wants to choose a board of 3 officers, president, vice president, secretary. Assuming the officers are chosen at random, what is the probability that the officers are Marsha for president, Sabita for vice president and Robert for secretary? Now, after having heard this problem so many times and being annoyed with me, what is going in your mind?
I can show you my paper.
Okay.
It's basically what I did.
Okay. But more than this one. Now tell me your thought process. What did go in your mind?
So I heard there's 9 people and 3 officers. So and each position has to be specific. Like it's not like combinations where so that can be president and then Marshall can be secretary. It'll be different. So it has to be a permutation and not a combination. So I just did 1 9 times 1 8 times 1 7 because I just didn't know how to put the other way. That's what I thought.
Okay. Okay. No, that's one good thought process. Let's see what Arush and Sai want to say, and Dave. Tell me a story. I'm very much interested in hearing your stories.
So, if it was a permutation, but it says like it doesn't say the order match, but like the order match is like they ask for like a specific position and what other people can do. So ask for like one should be like president, the other one should be vice president.
Okay. Okay. Arush, what is your story?
I think communication because like someone can because the order matters of what someone is. Because if someone's president or else secretary, you can like switch it around. If someone specifically wants to be this one. So order.
So, are you saying order matters or order doesn't matter?
It matters.
It matters. Right. See, yeah, Dave, what is your story? Tell me what is going in your mind. Okay. So let me read the question one more time for you. A club of 9 people wants to choose a board of 3 officers. Club of 9 people want to choose board of 3 officers. President, vice president and secretary. These are the 3 officers. Assuming the officers are chosen at random, what is the probability that the officers are Marsha for president, Sabita for vice president and Robert for secretary? If you are dealing with this kind of problem, what would go in your mind and how would you approach this? That's what I'm interested in. I'm not really worried about the calculation part right now.
Straight off the bat, we can see that it like belongs to certain positions, which shows like it is more functional for like another position once it's for a specific position, which shows that order matters as there's certain people that chosen a certain position.
Right. So see, whoever had said this question has put a very honest attempt to get us confused. Assuming the officers are chosen at random, that is the misleading part of the question actually. Saying, oh, at random, so the order doesn't matter. But here the thing is, it's like you have 3 chairs. Obviously these are officers who will grab 1 chair. Once you have picked up a person for this chair, there is no looking back. So it's essentially a permutation problem. Now I saw one solution that you have given, right? And I'm 99% sure that is the solution as well. But I will approach this problem in a different way. keeping permutation combination in mind, and then see if my answer and your answer matches, then that way we'll have two options. Yeah. So now it's like it's a permutation problem, that's evident. And if I have to find out the probability, Marsha in first position, somebody in second position, somebody in third position, we talk about the event, likelihood of this event is, everybody okay? Okay, with these tables I want to get a little careful. Sometimes I have seen that latch that you have, that slides down and then this folds. Okay? So be little careful. See the most safe position for this is when this is at the bottom. If it goes here, then it might fold. This is like a lock. So okay. So now it's a permutation problem for sure because order is mattering here for us. Okay. Now I have 9 people up from that I have to pick 3 officers. Since the order matters, that means the total number of ways I can permute them, right, will be this, right? Because if Marsha becomes vice president and somebody else becomes president, that is a change. Here we have to be sensitive about that, so that is a permutation problem. So total number of ways in which I can select 3 people from 9 members in the board is going to be 9p3, so it will be 9 factorial divided by 9 minus 3 factorial, which is 9 factorial by 9 minus 3 is 6 factorial. That means 7 into 8 into 9. This is the total number of ways in which we can pick 3 people from the group of 9, okay, with order being important. Dave, you are with me?
Yes, sir.
Arush, share with me? David, so far, no contention? No contention, right? Okay. Now, this is the total number of ways and we can pick 3 from the group of 9. Now, and here we are given a mandate that, okay, we have to find out the probability of situation when person A is president, person B is vice president, person C is secretary. So that is a fixed combination. Fixed 1 out of this many. That was the answer too. So, see again, any problem that we have, we can probably solve in a couple of ways. So, now we have two ways to look at it. One is, let's okay, fine. The order matters. I'm picking 3 from 9. I'm finding the permutation. This is my total number of events. And the situation that we have been asked about, 1 divided by the total number of events. Done? What you did was also perfectly fine. You said, okay, fine. First position, I have 1 out of 9. Second position, 1 out of 8. Third position, 1 out of 7. Done? Same thing. So permutation and combination don't exist by itself. This is an interpretation of what we know. It's just another way of doing the calculation. Dave, is that what clear?
Yes, sir.
Okay. Now this time we'll not try solving it, or maybe we'll try solving it. There is no harm in getting your hands dirty. You can always wash it later. Yeah. If you get your hands dirty, you can wash it, right? Okay. Let me go to the next question. And this one is again a loaded one, but once you read it a couple of times, it might look different. Samara is setting up an olive oil tasting competition for a festival. Somebody is setting up an olive oil tasting competition for a festival. From 15 distinct varieties, Samara will choose 3 different olive oils and blend them together. Dave, you are able to hear me okay, right? Samara is setting up an olive oil tasting competition for a festival. From 15 distinct varieties, Samara will choose 3 different olive oils and blend them together. A contestant will taste the blend and try to identify which 3 of the 15 varieties were used to make it. Okay? So she will pick 3, blend them together, contestant will taste the blend and try to identify which 3 of the 15 varieties were used to make it. Assume that a contestant can't taste any difference and is randomly guessing. What is the probability that a contestant correctly guesses which 3 varieties were used? A lot of content into it, right? So let's cut it down. So there is a olive oil testing event happening. Somebody who is kind of blending it is named Samara. I don't care about her name. She is picking from 15 varieties. From 15 varieties, she picks up 3 and blends them together. And then gives it to the individual like you and me. Say, okay, fine, you test the blend and tell me what are the 3 varieties that are used. And the assumption here is that contestant can't taste any difference and is randomly guessing. Okay? So what is the probability that a contestant correctly guesses which 3 varieties were used? Did you guys get the question here?
Yeah.
Dave, you heard the question right?
Yes.
Now, don't calculate. Tell me what is that this question is talking about and how would you approach this topic?
Okay, so it's 15 varieties and 3 different mixed together. And assuming that they're randomly guessing, that would mean that and no, so wait, I did this wrong. So that's so
You want me to like say how to solve it? Like classes percent?
A little louder.
You want me to solve it or
No,
process
you
to
tell me
solve
the
it?
process. What is going in your mind? and
Process
whatever.
for solving.
Mhm.
Okay, so for solving, so first you define out this combination or permutation. Because when he's guessing the combination of the different drinks, all of those, then there has to be a certain combination, a certain order, which you have to find out using either combination or permutation. And it's combination because order doesn't matter, like different all of those. Then you get a number from that, and that would be like the different combinations possible. And then out of those combinations, the person has to guess each individual oil, right? So it's like a 1 out of what is it? Wait. Never mind.
Okay. Sahib, what is going in your mind?
Where's the problem with like combination?
Uh-huh.
Then computation permutation is like specific to specific amount. I'm not that sure.
Okay.
Is the question?
Yeah.
I know it's combination because they never said that like it has to be in a specific order because it's 3 different ones blended. So say if I say X, Y, and Z, it's the same thing as blending Z, Y, and X.
Yeah.
So I know it's combination. I just can't figure out how to put this in my calculator.
Is the person that's tasting, do they know the 15 different flavors?
Yeah. They are aware of it. I mean, they are told that, okay, here are the 15 blends, and they don't have any test of it, right? I mean, Coke, when we drink Coke, we only know Coke as Coke. We don't know whether it has sugar, some cola, and then some soda mixed into it. And which one was put first? We don't know that. Yeah, Dave, I want to read your mind.
At first I thought it was stupid, but I think I'm doing combination. Because it's like, it doesn't like specify like which one is like those things. It's like yes, much more like
You want to know
yes, it has
eight? You want to know
Okay. So, a very, very out of the context question. Is the AC working for us? It seems to be working, right?
Yeah.
I mean, I'm not sweating, so that's a reflection of there is value for money. Okay, yeah.
So the person is guessing, it's just like they're blindfolded and they're just guessing the drink. It's like they're guessing 3 times in a row. And they usually get it right 3 times in a row.
So here, based on the question, right, it says that the person has he or she cannot guess based on the taste.
Yeah.
So it's like almost like blindfolded. You don't have any clue.
There is a blind guessing.
Yeah.
And what chances they get all 3 in a row?
Yeah. Correct.
how to put it in the calculator.
Uh-huh.
I got 1 out of 455.
1 out of 455. Selfie.
That's
Yes.
combination. I don't know. This is combination.
Okay.
That's if we get one. This is 3 or more.
So now let me. I'm pretty sure everybody's thinking in the right direction. So okay, I'll like the way I would want to proceed with this one, right? So what? Okay, can I have everybody attention, please?
Yeah.
So I'm reading the question one last time. Okay? Samara is setting up an olive oil testing competition for a festival. From 15 distinct varieties, Samara will choose 3 different olive oils and blend them together. When I'm making tea, sugar, milk and water, which one is mixed first, I don't care. For me, it's a combination that matters. So it's a combination. And taste will also not change by blending them, right? A contestant will taste the blend and try to identify which 3 of the 15 varieties were used to make it. Assume that a contestant can't taste any difference and is randomly guessing. What is the probability that a contestant correctly guesses which 3 varieties were used? So it's a question of blindfolded guess, as simple as that, from a combination. Yeah? So we have 15 olive oil varieties and this lady, Samara, is picking up 3 to blend them. Okay? So first of all, we have to look at how many possible varieties she can make. How many possible combinations she can make. Yeah.
455.
Okay, so I don't know how much is that. I will use this. 3 combinations out of 15 options. So that becomes 15 factorial divided by 15 minus 3 factorial multiplied by 3 factorial. Yeah? And that is 15 factorial divided by 12 factorial divided by 3 factorial. So this becomes 13 into 14 into 15 divided by 3 into 2 into 1. So 3 into 2, 5 times 3. So this becomes 14 3 ja. Okay. So 13 1 13 plus 5 18 into 3. This is 3 2 ja 6, 3 is 24. Give me the 3 plus 2 5. 546. Was that the number that you were talking about? 546?
I got 455.
So 13, 14, 15 divided by 6. How did you get that?
Because I did 15 combination.
15 combination 3.
Yeah.
So that will be 15 factorial divided by 15 minus 3 factorial divided by 3 factorial. Okay, this gives 455.
Yeah.
Okay, let me make sure that I am not missing something. 13, 14, 15, 3 into 2, 6. 3 into 2 is 5 times 3. 14 3 ja. No, it's not 455.
I'll try it again.
How much did you get?
I got
455 is good. 15 C3 cannot give us. Am I missing something? 13, 14, 15. 3 to 2. 3 to 2, 6. Oh, my God. Now I know.
You can combine it.
Yeah, so 3 into 2. 3 gives me 5. And this 2 gives me 7. 13 7 is 91 into 5. 5 1 is 5. 5 9 is 45. Yeah. Calculator is not wrong. Okay. So this is the total number of ways she can create the blends. And there is only one blend that is right. There is only one. So basically, this many combinations of blend that Samara can make. And if I am making a blind guess, my possibility of getting it right will be 1 out of this many. Yeah?
Yeah.
Yeah? Dave,
Which one is this?
making sense? Arush? Is this relatable? That's the first thing.
Yeah.
I mean, you guys can excuse me for my wrong calculation, but I'm asking from approach point of view. Yeah?
He wants to know the calculating.
I'm sorry?
He wants to know the calculating outcome.
It's called calculating.
Okay, so just to summarize this, right? When we had a question like this, it says we have to find out the blend of three olive oils, and obviously when you are blending A, B and C or B, C, A, C, B, doesn't matter because it becomes a combined compound which will have its own taste.
Yeah.
And it's told that by tasting it you cannot guess. Everything is same taste, right? It's probably only the quality that matters. So from this question, one thing is evident that we are trying to find out the different unique combination of 3 olive oils that we can create out of 50. That gives me the total number of combinations that can be made. And if somebody is guessing, there is only one right guess. And that probability of that guess being right is 1 out of the total number of possible blends that you have, right? I mean, it's like I have 1 to 455 written in different piece of paper. I have to blindly pick one, and that number being number 25 is 1 out of 455 that I have. Yeah, they making sense? You are the only guy whom I am not able to see, whose facial reaction I am not able to see. Everybody else here in the classroom, I can see who is thinking good or bad about what I am doing right now. Okay. So now let's look at the next question, and we will not try solving it. This time I will keep my mouth shut. Somebody has to explain. Standard deck of 52 playing cards include 4 aces, 4 kings and 44 other cards. A standard deck of 52 playing cards includes 4 aces, 4 kings and 44 other cards. Suppose that Louis randomly draws 4 cards without replacement. What is the probability that Louis gets 2 aces and 2 kings in any order? Reading one more time. Let me read one more time and then I'll... A standard deck of 52 playing cards includes 4 aces, 4 kings and 44 other cards. Now I can see Dave's expression. Okay. A standard deck of 52 playing cards includes 4 aces, 4 kings and 44 other cards. Suppose that Louis randomly draws 4 cards without replacement. What is the probability that Louis gets 2 aces and 2 kings in any order? Heard the question, Dave? Okay. Now deal with it and then teach me.
Are we allowed to work together?
Does symbol matter? Does a symbol matter?
Symbol? No, it says 2 aces and 2 kings in any order. That's the clue. So brainstorm this and tell me what is that you want your teacher to be aware of. Yes, Dave.
Wait, so you want like that
Yeah, the approach part. I mean, how would you think about it, and then you can tell me the mathematical side of it.
Okay, the way I learn it is like, first, we do like choose how many ever pieces. Like, 4 pieces, choose 2, because we want 2 aces. And then since if we need 2 aces and kings, we would do times, total amount of kings, choose 2. And then we would do over the number of cards, choose 4, because we want 4 cards with 2 pieces and then 2 kings.
Okay. Okay. I will reserve this option for now. Let's see what else I'm hearing in the class. So Dave, a question to you, or everybody in the class. I'm sure you guys would have dealt with other teachers also in the past. Did you find such a bothering teacher in the past who keeps bugging every child?
You're not bothering.
Now I'm bugging you guys. I'm forcing you guys to think. Okay, I mean that's my intent. Okay?
Yeah.
So otherwise, we can. I will go with a monologue for 1 hour and then say, "Okay, class is done." That's not the way I love it. Okay. Any bad experience, good experience, Dave? Before Dave is staying out of controversy. Say, okay, both ways. All right. Let's see what else.
Should we start?
Tell me the approach. I can solve it for you guys, but tell me the approach first.
It's gonna be combination, because order doesn't matter.
Uh-huh.
And then it's either flipping two cards, so two factorial, because 4 plus 4, 4 is 4 things plus 4 for cards.
Uh-huh.
Deck of cards, 2. This says 52 factorial,
Uh-huh.
and that's over. Then we want 4 options, so I don't know, like 4 cards that we want. 2 aces, 2 queens. But the chances is that
What is your story? Tell me.
Okay, so there's 4 aces and this. I did this like out of pure logic. I didn't think about permutations or.
You don't have to.
combinations.
Yeah.
So there's 4 aces and 4 kings and 44 other cards. So I did 4 out of 52 times 4 out of 52, which equals to 16 over 2070, 2,704, and I simplified that to 1 over 606.
Okay. Now, Sahib, what is your story?
I have the same thing, I think it was a combination, but I'm kind of going to
Okay. Now let me break it down for you guys, and this might make you think in a different direction. I'm not still ruling out any of the options. You guys might have gotten the same answer as what I might get, but let's see. It says standard pack of card, meaning it has 4 varieties: spade, diamond, heart, and club. Yeah. Yeah. So that means we have 4 A's, 4 Kings, 4 twos, 4 threes, and all the 4 varieties. Yeah. Everybody with me? It says, what is the probability of somebody getting 2 aces and 2 kings in a pick of 4? Now, since the order doesn't matter, first thing is we have total 52 cards. From that, how many ways we can pick 4 cards? This is my total number of picks, right? Since the order doesn't matter whether first A, then king, then A king, or A king king, king king A, doesn't matter. So as long as we have 2 A's and 2 kings, that is fine. So that means it's a combination scenario. How many ways I can get or pick 4 cards out of 52? This is my total number of events. With me so far? Yeah? Sahib, Arush, here. So first thing first, this is my total number of ways I can pick 4 cards, or I can form group of 4 cards. Yeah? And now, how many ways? I have 4 aces and I have 4 kings. Here the ask is, what is the probability of getting 2 aces and 2 kings? Now, if this is my total number of events, I am talking about how many ways I can get 2 aces out of 4 aces and 2 kings out of 4 kings. This is my likely event, this is my total event, and this is what will give me the probability. So, see, you have 4 aces and you have 4 kings. How many ways you can find 2 aces out of it? How many ways you can find 2 kings out of it? Yes, you were saying something.
So don't the 4's, both of them add up to even if you multiply them, won't they still both be 1? Because you said any way, so that means 4 aces in like 2 aces in any way is still 2 aces, so that's only 1 way.
No, so here you had 4 options, 4 A's. You had diamond ace, you had spade ace, you had club ace, and you had heart ace. Here the question is, how many ways you can get 2 aces? So you can get heart and spade, you can get heart and spade, heart and ace, heart and diamond, heart and spade, heart and club, club and likewise you can think about it. And it doesn't really matter which one comes first. So you are talking about how many ways you can get 2 aces out of the 4 options you have. Yeah? How many ways you can get 2 kings out of the 4 options you have? Little bit digestible? Okay. So these are the number of options, these are the number of ways I can get 2 aces and 2 kings. Divide the total number of ways I can pick 4 cards out of 52. Now you calculate and tell me what exactly it is. 4C2 is 4 factorial by 2 factorial, 4 minus 2, 2 factorial, into 4 factorial by 2 factorial, 2 factorial, divide by 52 factorial, divide by 52 minus 4, 48 factorial, 4 factorial. Now this becomes 4, so this becomes 2 into 2, 4, so 3 into 2, 6, into 6 divided by, this becomes 49, 50, 51, 52.
It's not a good fraction.
Into 4, 3, 2.
Yeah.
Yeah? Yeah, you deal with it. So again, what the calculation is this part, I will leave it for you guys. How are we approaching these kind of problems is what is important. And even if you just forget about the combination, permutation things, right? The thing that we have to consider while approaching this kind of problem is, okay, what is the total number of ways I can pick A's? What is the total number of ways I can pick 2 kings? Okay. And what is the total number of events what is the total number of combinations that I can make out of 4? Out of that, how many are 2 kings and 2 ace combination? Make sense? Okay. So now you guys will think that, okay, today what we did for last 1 hour, what was the outcome from this whole discussion? Honestly speaking, we did not learn anything new. We did not learn anything new. What we are doing is, whatever we learned with permutation, whatever we learned with combination, we are trying to apply those concepts to see how these 2 concepts marry with probability concepts to help us find out the likelihood of any event or probability of any event. Right? When we started with probability, we said, okay, fine. What is probability? Probability is the likelihood of an event divided by total number of events. Now, how do I find out the likelihood of event? Based on whether the ordering matters or it doesn't matter. We'll choose permutation or combination concepts and then glue them together. Yep. You're done. You're done. So, and again, whatever we have done in the class, this is never enough. So, my humble request to each one of you would be, look for opportunities to challenge your teacher, look for opportunities to educate your teacher also. Okay? Meaning, when you go to do the unit test, with whatever understanding you have, use that for doing the unit test in the Khan Academy itself, for that particular topic, and see if you are able to solve it without any extra attempt or not. If you are able to do that, okay? With that being said, I will let you guys go. Have some fun in the evening and we'll come again on Saturday. Yep. Good night.
Yes, sir.
Yep. Alright, bye bye.